Hello, good evening, friends. Today I'm going to discuss the chapter of basic thermodynamics. So, basic thermodynamics. This paper covers 8 chapters, and 8th chapter is, first one is basic concept of thermodynamics. Second one is energy interactions. Third one is first law of thermodynamics. Fourth one is second law of thermodynamics. Fifth one is entropy. Sixth one is available energy, availability, and irreversibility. And there is first, second, third, fourth, fifth, sixth. Now seventh one is properties of pure substances, and last one, eighth one is thermodynamic relations. So, basic concept of thermodynamics is the first chapter. Second one is energy interactions, and third one is first law of thermodynamics. Fourth one is second law of thermodynamics. Fifth is entropy. Sixth is available energy, availability, and irreversibility. Seventh one is properties of pure substances, and eighth one is thermodynamic relations. These are the 8 chapters. Now we have already discussed about the weightage of the basic thermodynamics in ESE and GATE examinations. Again, I am going to tell you, in ESE examination, in objective section, 18 questions will be asked, and approximately in conventional question 40 marks questions will be asked in ESE examination, and in GATE examination the weightage of basic thermodynamics is approximately 11 marks out of 100. 11 marks questions will be asked in GATE examination. So there is only 8 chapters, and this is the weightage. Now, as we have already discussed these 3 chapters in previous classes, now I am going to start next chapter, that is second law of thermodynamics. Second law of thermodynamics. Okay. Now, I'm not going to wait. Okay. I think you have noted down. Okay. So, second law of thermodynamics. Second law of thermodynamics. Dear students, as we know that in thermodynamics, first law of thermodynamics simply says that energy is conserved. First law of thermodynamics simply says that energy is conserved. But it do not tells us about the direction of any particular process. So it is the second law of thermodynamics which gives the direction for particular processes with the concept of entropy. Okay, so we can say second law of thermodynamics is also known as directional law. In thermodynamics it is also known as directional law. Okay, now we know heat is low grade energy and work is high grade energy. It is low grade energy and work is high grade energy. So the complete conversion of low grade energy into high grade energy is impossible in a cycle. So complete conversion of low grade energy is in high grade energy is impossible. It means heat is not going to completely converted into work. Okay, some losses will be there. Okay, now I think you have understood. So I'm not going to, yes, what not? Okay, not down. First law of thermodynamics simply says that energy is conserved, but it not tells us about direction, but it is second law of thermodynamics which gives the direction for particular processes. by the concept of entropy. Okay, so this is known as directional law. Now, complete conversion of low gauge energy into high gauge energy is not possible. Now, I am going to tell you about the thermal energy reservoir. Thermal energy reservoir. Thermal energy reservoir. There are two types of thermal energy reservoir. One is source and another is sink. Source and sink. These are the thermal energy reservoir. Source is a type of thermal energy reservoir which can supply continuous energy without undergoing any temperature change. Okay? Source is a thermal energy reservoir which can supply thermal energy continuously without undergoing any temperature change. Okay? Now, another one is sink. So this is also a type of thermal energy reservoir. Which can absorb thermal energy continuously without undergoing any temperature change. This will supply and this will absorb. Okay? So write down. Shows the thermal energy reservoir which can supply continuous temperature without, you can say thermal energy without undergoing any temperature change. Okay? So the thermal energy reservoir which can supply thermal energy without undergoing any temperature change. Next one is, this is also a thermal energy reservoir which can, here is supply and here in case of sink there will be absorb, which can absorb thermal energy continuously without undergoing any temperature change. Okay? Understood? Now, now I am going to start the laws of statements of second law of thermodynamics. I am going to start the statement of second law of thermodynamics. So there are two statements. Of thermodynamics. Sorry, second law of thermodynamics. second law of thermodynamics. First one is Kelvin Planck statement. First one is Kelvin Planck statement, and second one is Clausius statement. Okay. Both the statement is similar, and you can say it is both the statement is same, has same meaning, but the statement is different. Carefully listen. Kelvin Planck statement. Kelvin Planck statement says it is impossible to develop a device. It is impossible to develop a device operating on a cycle which produces work continuously with a single reservoir. Okay. Kelvin Planck statement. It is impossible to develop a device operating on a cycle which produce work continuously with a single reservoir. Okay. Now see, perpetual motion machine of second kind. Perpetual motion machine of first kind we have studied in what? In first law of thermodynamics. Here I am going to tell you about the second kind of perpetual motion machine. Okay. Now see, it is impossible to develop a device operating on a cycle which produces work continuously with a single reservoir. This is Kelvin Planck statement. If it is possible, it is impossible, but if it is possible, then the device name will be PMM2. If it is possible, okay? If possible, the device is named as PMM2, perpetual motion machine. Of second kind. First kind we have studied in first law of thermodynamics. Okay. So Kelvin Planck statement says that it is impossible to develop a device operating on a cycle which produces work continuously with a single reservoir. This is not possible. Okay. And if it is possible, means PMM2, device name should be PMM2, and PMM2 is impossible. PMM2 is impossible. According to Calvin Planck statement, perpetual motion machine of second kind PMM2 is impossible. This is also an objective question. According to second law of thermodynamics, a statement of Calvin Planck statement, a statement of Calvin Planck, according to Calvin Planck statement, PMM2 is impossible. Let us consider there is a reservoir, and we have already studied about the source and sink. Okay, so let us consider a reservoir and consider a PMM2 machine. Okay, so I'm going to so this is a reservoir. Let us consider this is a reservoir, and there is a machine PMM2. Okay, and this PMM2 is going to supply continuous work done. Okay, so PMM2, this is PMM2. Okay, this is a reservoir and this is a PMM2 machine, and which supply work continuously. Means according to Calvin Planck statement, this is not possible. This is a reservoir, single reservoir. Okay, this is single reservoir, not more than not more than one reservoir. Single reservoir, machine, perpetual motion machine of second kind, and what? It is not possible according to Calvin Planck statement. Calvin Planck statement of second law of thermodynamics tells us about the PMM2 is not possible. Okay, so it is not possible. Okay, carefully listen. This Calvin Planck statement gives the idea of heat engine. How we will construct heat engine? So heat engine is a logical development of Calvin Planck statement. I will explain after a little bit of time. Okay, so this is the Calvin Planck statement, and now I am going to tell you about heat engine. What? Heat engine. Heat engine. Okay, so this is not possible. This is not possible according to Calvin Planck statement. But now there is a reservoir. First reservoir. Let us say source. There are two reservoirs. There are two thermal energy reservoirs. Okay, source and sink. So consider this is source, and now there is a machine. Heat engine. Okay, heat engine. Now it will supply work continuously. It is possible or not? It is not possible according to PMM2 with a single reservoir. Okay, now we will add another reservoir. And this reservoir will be sink. Okay, now Now there are two reservoirs. There are two reservoirs, and there are two reservoirs, and it produces work continuously. It is possible. Okay? It is possible. This was not possible, but this is possible because it is not with a single reservoir. It is with two reservoirs, source and sink. And source is a reservoir which supply continuous energy without undergoing any temperature change. And sink is a reservoir which absorbs thermal energy continuously without undergoing any temperature change. So work will be produced continuously in a cycle. Okay. Now see, this is the heat engine. So second law of thermodynamics. From the second law of thermodynamics, and with the help of Kelvin Planck statement, heat engine is developed. Okay. So heat engine is the logical development of Kelvin Planck statement, not the Clausius statement, not the logical development of Clausius statement. I am saying that it is the logical development of Kelvin Planck statement. Okay. Now you can write down the efficiency. So efficiency of heat engine. Efficiency, we know that efficiency is output by input. Efficiency is output by input. Output is here. Output is the work, and input is the this one. Let us consider this is Q1 and this is Q2. Okay. So efficiency, this efficiency is equal to output means work divided by input means Q1. This is efficiency, and from here we can say W is equal to see Q1 is equal to Q2 plus W. Q1 is equal to Q2 plus W. Okay. So work is equal to W is equal to Q1 minus Q2. Q1 minus Q2 is equal to W. Okay. So efficiency is equal to Q1 minus Q2 by Q1, or you can say efficiency is equal to heat engine का efficiency is equal to 1 minus Q2 by Q1. 1 minus Q2 by Q1. So this is efficiency of heat engine. Okay. Now Q2 is heat rejected or supplied. Q2 is equal to heat rejected and Q1 is equal to heat supplied. So finally we can write efficiency is equal to 1 minus Q rejected by Q supplied. So this is the efficiency. of heat engine. This is the efficiency of heat engine. So Kelvin Planck statement gives the concept of heat engine. Okay. Now this is a very important question, many times asked in the ESE examination, that the heat engine is the logical development of which statement? Clausius, Kelvin or Carnot? Okay, so the answer will be Kelvin Planck statement. Okay. So now second statement, of second law of thermodynamics, that is Clausius statement. Clausius statement. So Clausius statement of second law of thermodynamics. Clausius says it is impossible to develop a device operating on a cycle which transfers heat from lower temperature to higher temperature, without any external work input. Okay, so it is impossible to develop a device operating on a cycle which transfer heat from lower temperature to higher temperature without any external work input. Okay. Clausius says it is impossible to develop a device operating on a cycle which transfers heat from lower temperature to higher temperature. Let us consider there is a reservoir. Okay, a reservoir T1 having T1 temperature and another reservoir having T2 temperature. Okay, now there is machine here. Okay, now this is say Q2 and this is Q1. Okay, are you getting? So this is Q2, this is Q1. It is impossible to develop a device operating on a cycle which transfers heat from lower temperature to higher temperature. Let us consider T2 is less than T1 or Q2 is less than Q1. Okay, this temperature is low and this temperature is high. Okay, so lower temperature, from lower temperature to higher temperature, heat transfer is not possible according to Clausius statement. Means this is not possible. This is not possible. Okay. Now see. This is not possible without any external work input. Without any external work input. So let us consider this temperature is lower, this temperature is lower, this temperature is higher. This is source, this is sink. Okay. Now this is not possible, but if we will add a external work input means if we supply external work input, then it will be possible. Clausius statement says that from lower temperature to higher temperature, without external work input is not possible. But with external work input it will be possible. Okay. Now listen, this is also a machine. Okay. Now I am going to tell you about refrigeration. What is refrigeration? Refrigerator is a device and refrigeration is a process. Okay. So I am going to discuss a refrigerator. Okay. So refrigerator is a device which maintains lower temperature compared to surrounding. And as lower temperature is to be maintained, therefore it should operate on a cycle. Okay. So now see, this is Q2 temperature, this is Q1 temperature. Okay. This is Q2 temperature, this is Q1 temperature. So this device is possible. Okay. We have to maintain the lower temperature in the refrigerator. Okay. We have to maintain the lower temperature in refrigerator. So T2 is the temperature, lower temperature. T2 is the lower temperature. Q2 is the heat, and Q1 is the heat about T1 temperature. Q2 is the heat about T2 temperature. So this is possible. From T2 to T1. This is a refrigerator. Say it refrigerator. Means lower temperature to higher temperature with the help of work is possible. This is a refrigerator. Okay. Now see, this is storage temperature, and this will be the surrounding temperature. In refrigerator is simply refrigeration is a process. A lot of device work on that, but you can consider refrigerator in your domestic refrigerator in your houses. So this is storage temperature. Storage temperature, and this will be the surrounding temperature. Okay. Now there is term coefficient of performance, COP. Now there is term coefficient of performance. Coefficient of performance of refrigerator. So coefficient of performance is equal to desired effect by work input. Desired effect by work input. And what will be the desired effect? Desired effect will be Q2. Q2 means lower temperature. Storage temperature will be lower temperature. So Q2 is equal to Q2 divided by what? Divided by Q2 divided by work input. Q2 divided by work input. And now work plus Q2. Work plus Q2 is equal to Q1. Work plus Q2 is equal to Q1. So work is equal to Q1 minus Q2. Work plus Q2 is equal to Q1. Okay. So work is equal to Q minus Q2. So is equal to Q2 divided by Q1 minus Q2. So this will be the coefficient of performance of COP of refrigerator. Okay. Now this is a brief introduction about the refrigerator. How to develop refrigerator from second law of thermodynamics. Refrigeration and air conditioning is a paper. Okay. So this is the brief application of second law of thermodynamics. Now there is another thing, heat pump. Now see, heat pump. Sorry. Desired effect. Okay. Now heat pump. Heat pump. Now heat pump is a device which maintains higher temperature compared to surrounding. Okay, heat pump is a device which maintains higher temperature compared to the surrounding. Now see, this is temperature T1 and this is a device and this will be the temperature T2. Okay. Now you can say heat engine. Okay. So also according to the clauses statement, if we provide work input, then this cycle will be completed. Okay. So this is equal to Q1. Now heat pump coefficient of performance of heat pump is equal to what? Desired effect again same, desired effect by work input. So here the desired effect is what? Q1. Also T2 is less than T1. Okay, T2 is less than T1. So here the desired effect is Q1. Why Q1? Because it is higher heat than Q2. Okay. In the case of refrigerator, the desired effect was Q2. But in the case of heat pump, the desired effect will be Q1. So is equal to Q1 by work input, and here in this case work plus Q2 is equal to Q1. It means W is equal to Q1 minus Q2. Therefore coefficient of performance for heat pump is equal to Q1 divided by Q1 minus Q2. So this will be the coefficient of performance for heat pump. Now see, now see, coefficient of performance of heat pump minus coefficient of performance of refrigerator is equal to 1. This is very important equation and one of the repeatedly asked question in the examination. So this is the heat pump coefficient of performance and this will be the coefficient of performance for refrigerator. So this minus this will be this. This is very important questions for PSU purpose or ES purposes. So thank you very much for today's lecture, and next lecture in next lecture we will prove that the both statement Clausius and Kelvin Planck statement is same. How it will be, and also as we have studied about the heat engine, that the heat engine is the logical development of Kelvin Planck statement. In the same way, heat pump and the refrigerator, heat pump and refrigerator is the logical development of Clausius statement of second law of TG. Okay, this is also very important questions, objective question, which has been regularly asked in the PSU and ESC examinations. So in this session, this is the required things, and now in next session we will show the Kelvin Planck statement and the Clausius statement are equivalent. Okay, this will be also very important thing, and to show that these two statement is equivalent, this is important, and this type of questions will be asked in interview, mostly interview. So this is a brief knowledge about the second law of thermodynamics, in which we have studied about the heat engine, refrigerator, heat pump, and two statements of second law of thermodynamics, and about the directional law. Okay, thank you very much for listening me, for learning from me.